Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In the previous unit, we saw how to find out moment of inertia. Today, we will start with the next unit, that is simple stresses and strains. Now, in my first lecture of strength of material or mass, I have explained the difference between the strength of material or mechanics of structure and applied mechanics. It was regarding the bodies. Okay, so let us start from a body. Okay, so let us see what do we mean by a body. Here it is expected that any particular machine component is a particular body or any part of the structure is a body. Okay. So what is a body? Body is a matter which is limited in all the directions. If I say so, this is a body which has got limit in this direction, limit in this direction, limit in this direction, like this. So, body is a matter which is limited in all the directions. Now, what do you mean by this? Look here now. This is a duster. It has got some material which has got limitation up to this, here up to this, here up to this. So this is a body. So a body is defined as a matter which is limited in all the directions. Okay. Now let us see what are the types of the bodies. The bodies are of two types. One is rigid body and the second is deformable bodies. So what do we mean by a rigid body? The body which does not change its shape and size even after the external load is applied is known as rigid body. Okay. So the body which does not change its shape and size even after the load is known as rigid body. And if you remember, in the second lecture I have told you that all the bodies which we have considered in applied mechanics were rigid bodies. Okay. Now let us see what do we mean by deformable bodies. Now the body which changes its shape and size when the external load is applied to it is known as deformable body. Now the deformable bodies are further divided into two types. One is elastic bodies and the second is plastic bodies. Now what do we mean by elastic bodies? The body which changes its dimension when the load is applied to it, but comes to its original dimension after removal of the load, is known as elastic body. So the body which changes its dimension due to loads but regains its original dimension after removal of the load is known as elastic body. Now what do we mean by plastic body? The body which changes its dimensions due to loading but do not regain its original dimensions completely after removal of the load is known as a plastic body. As far as mechanical engineering is concerned, the shaping and forming such operations are done on the body when the body is in plastic state. Okay? Now, if you remember in the second lecture, I have told you that all the bodies which we are going to consider in strength of material or mechanics of structure are assumed to be elastic. So this was the basic difference between applied mechanics and strength of material or mechanics of structure. Therefore, again I will repeat it. You can write down the definitions from the book. Body is a matter which is limited in all directions. Body is of two types: rigid bodies, deformable bodies. The bodies which do not change their shape and size due to loading are known as rigid bodies, and the bodies which change their shape and size due to loading are known as deformable bodies. They are of two types: elastic and plastic. Okay, so this is first one, that is body. Body is of two types: rigid bodies and elastic body. Okay, now let us go for the next one, that is what are the different loads which are acting on the body. Now you have to keep in mind one point: hereafter in SOM or mass we will always talk about, whenever I will say a body, that body will always be an elastic body. Okay? Now let us see what do we mean by axial load. Now consider a body of definitely what type of material? Elastic material. Now the imaginary line joining the top and bottom cross section of this particular body is known as axis of the body, you know. If the line of action of the load coincides with the axis of the body, then it is known as an axial load. You can very easily see that this line of action of this load, you may say that the load is, say, P. It is coinciding with the axis of the body. Therefore, it is known as axial load. Now, one more figure I will draw. Again, consider A body definitely of what type of material? Elastic material. Okay. Now this is the axis of the body. And this is the external load applied on the body. So now here you can see that whenever the line of action of the external load coincides with the axis of the member, that is known as axial load. Here also the load is axial, here also the load is axial. But what is the difference? Here the nature of the load is pulling. Okay, so this nature is a pull. And therefore this particular body is said to be in axial tension. So what do we mean by axial tension? When the body is subjected to the axial load of pulling nature, it is known as axial tension. Now what is happening in this case? In this case, the loads are pushing. The nature of the load is pushing. So this is known as axial push. And whenever the body is subjected to axial push, it is said to be in axial compression. Okay, so do you understand what is axial load? When the line of action of the load coincides with axis of the member, it is known as axial load. If the nature of the load is pulling, then it is axial tension or tensile load, and when it is pushing, it is axial compression, that is compressive load. Okay, now here you can very easily see that the load which is acting on the body is perpendicular to the cross section. Okay, so here the load is axial, that is perpendicular to the cross section. Now many a times load acts along the section, that is tangential load. Now how it is, I will show you by a figure. So let us say A, B, C and D is a block of elastic material which is fixed at the base. If the load is applied along this top surface, this type of load is known as tangential load. Okay, this type of load is known as tangential or shear load. Tangential or shear load. Okay. Now, we will consider one more. Consider a bar of elastic material. And if it is subjected to the couple or movement like this, and here it will be, come on, here it will be like this. Okay? So this type of action is known as torque or twisting load. So when we are rinsing our clothes after washing, that is twisting. Okay? Now, these are axial loads, axial pull, axial push. This is tangential load, that is shear, and that is the torque. Okay? One more type of load is like this. This is a member of elastic material. Say it is a beam like this, and it is subjected to the load like this. This type of load is known as transverse load. Okay? So we can say that number one is axial tension, axial load. Number two is pulling nature, that is axial tension. Axial load of pushing nature is axial compression. Then the third type of load is tangential load, which is a shear load, you can say. Fourth type of load is a torque, and the fifth type of load is transverse load. Now these are the different types of loads which can act on a member. Now mind well, these loads can act simultaneously on the member. Now let us see what is the effect of these loads on the members. Now I have already told you that all the bodies are elastic in nature. So whenever load will be applied, they will deform. Now that is what I am going to tell you about deformation. What do you mean by deformation of a body? The change in dimensions of the body due to applied external load is known as deformation of the body. Okay? Whenever we will apply the load on the body, there will be changes in its shape and size, dimensions. That is known as deformation of the body. Depending upon the type of load, the deformations may be in the form of extension in the first case, this body due to the load will extend. This red color I am showing you the body after application of the load. So in case of axial tension, there will be increase in the length of the body. So deformation will be in the form of extension, that is tension. In case of pushing load or compressive load, the deformation will be contraction. Contraction means what? Decrease in the length. Now I am talking about length only, but if you see carefully, in case of extension, the length of the member will increase, but the cross-sectional dimensions will decrease. In case of push, the length will decrease and cross-sectional dimensions will increase. Now the deformation will be in the form of angular deformation in case of shear load. So see, look here, whenever you are performing the job in the workshop in first year, whenever you are using the jack plane on that wooden piece, okay, you are applying the load tangentially. When you are shaving, that load is applied tangentially. So due to tangential load, what will happen? This block will get distorted to this shape. And if I say this is phi, then this phi will be the angular deformation. Whenever you are applying a torque, means I have told you after washing the cloth, when you are rinsing the cloth, you are applying the couple moment here like this and here like this. So they are opposite. So that is known as twisting. Okay? Due to twisting load, the deformation will be in the form of twisting. Okay? And whenever the load is transverse load, okay, what will happen? This transverse load, due to this transverse load, this will be bending. Therefore, depending upon the type of load, the deformation. What is deformation? Change in shape and size of the member due to application of load is known as deformation. The nature of deformation will depend on the type of load. If the load is tensile, the deformation will be extension, that is increase in length and decrease in lateral dimension. If it is push, decrease in length, increase in lateral, that is cross-sectional dimension. Here it is angular deformation. In case of torque, it is in the form of twisting, and in case of transverse load, it is in the form of bending. So this deformation can be extension, contraction, bending, twisting, or angular deformation, depending upon what is the type of load acting on it and their magnitude. Okay, so here we will stop. In the next lecture, we will see how this deformation is resisted by the material of the body. Thank you.